All right, welcome back. This is lesson 2 for the basic Unix component of the Bioinformatics Virtual Coordination Network. We're working through the Happy Belly Bioinformatics tutorial. The link is in the description below. What we're doing now is we're on file 2, or lesson 2. Lesson 1, we talked very briefly about how Unix is structured in terms of commands, how they work, how we incorporate optional parameters, how we incorporate our arguments as we're going along. We learned how to move around using the CD command. We learned where to look for where we are relative to both the root directory and the home directory. And how that functions for us in terms of the overall structure of where we are on the computer. In this example, we're going to talk about working with files in particular. And we'll talk about how the types of files that we can work with, how we can work with those files directly, and then some tips about working with those files in various directories. Okay, so the first thing that we want to do is we want to make sure everybody starts in the same place. So if you were just doing lesson 1 and you might be in a different directory, we're all going to type this as our starting command, cd tilde. We're going to use the absolute path of our home directory. We're going to use a tab completion there after I type the UN to get Unix_intro and then hit enter. I happen to be there already, but in case you weren't, now we're all there together. All right, so one of the commands that we worked with in the first lesson was head. And so head, when we type it for example.txt, it gives us our first 10 lines of information. Interestingly, there is a complementary command that goes along with head called tail. And tail will print the last 10 lines of our file. So if we do tail example, oh, see, this whole time you thought that example.txt was only 10 lines. It's actually 100 lines. And so here, tail has given us our last 100 lines of text in the example.txt file. And so these are particularly useful when we're working with big files. So right now, this example might only be about 1 kilobyte in size, right? It's really easy. If we wanted to, we could open this up. We could scroll through all 100 lines and say, oh, it's a 100-line file. If this was a 10 gigabyte file, a very large file with lots and lots of text in it, and we wanted to see how the first line compared to the last line, head and tail would give us that opportunity without having to open up the whole file and see what the contents look like. The other way we can normally, and this is the way that I will regularly check the contents of a file, is using the command less. There is a complement more. It doesn't do as many functions as less does, or does different functions and is slightly less useful than less is. So we can do less example. And so now what I've done is I've taken the text file that is example.txt and I've opened it up into active memory of the computer. And so this allows me to look at the contents kind of very similarly you would be used to a regular text document in something like Microsoft Office or Google Docs. And so I can scroll down, and you can see the numbers counting upwards. I can scroll up. I can move in really big chunks by hitting Control B. Sorry, not Control B. We want to do space. Sorry, Control B is the next one. That's why I follow along the tutorial, Ben. Just do the tutorial. So if we do space, we actually move down whole pages at a time. And because there's all 50 lines were present, I move most of the document. You can keep hitting space to go down. Now, if I hit Control B, or the equivalent on your computer, I can go up in very large chunks up the file as well. So you can move in various ways. You can move down one line at a time. You can move whole pages at a time. There are lots of opportunities to use less to look into a file. Less has a lot of, or doesn't have a lot of issues. It has the same issues as a lot of other programs might have. So if you're trying to open up a large document to work through in less, it will take up more memory. It might take more time to open. It might be slower to process through. So you should keep that in mind. If you're expecting your file to be very large, less might not be the best way to process through your files, but it still, that first page of information will still present pretty quickly, and it will give you an idea of what the contents of your document are. To stop using less, we can hit the command Q, and that will bring us back to our terminal space. and it'll allow us to continue on. And so the next command that we're going to work with is WC, which stands for word count. And so if we do word count example, it's going to give us a number of elements back. And the way we interpret this is like this. The first number gives you the number of lines in the document. The next number gives you the number of words. And so words here are defined by strings of characters between white space, right? So there are 400 words in this document, which makes sense because if you look at it each line, there are 4 words per line. There are 100 lines, 4 times 100, 400 words. And then the last number is the number of characters. And so that's counting non-white space information and giving you that back as a whole number. And so one of the things that's here is the quick practice is how do we get only the number of lines from the file word count? And so we could do this in a couple of ways, right? The last lesson we learned that a lot of these files might have a help document. So if we do word count -- help, we get some information here about what is going on there. And so if we wanted specifically just to print the lines, this number, how many lines are present, we can use a -L to just do that. If we wanted just the characters, it would be -M. If we wanted just the words, it would be -W. So let's do that. So we can do word count. I'm going to open up this solution. So we can do word count -L example.text. Oop, and there you go. So now instead of giving us all 3 numbers back, it's just giving us the first number, the number of lines. And so this can be incredibly useful. So along the lines of head and less and tail, which give us the contents of the information that we're looking at, when we start working with very large numbers, you might write a file and say, okay, I'm expecting 500 results from this. And you can count very quickly how many results you get. And if it's more or less, you know that what you did didn't actually work the way you were expecting it to. And so word count is something that is a very commonly used tool and will probably become part of your normal interactions with Unix going forward. Okay, so we're going to talk here very briefly about how Unix works with almost exclusively plain text files. And so what is a plain text files, or also they're sometimes might be referred to as a flat file. So these are the basic Word documents or text documents in their purest form, right? So they're very commonly seen extensions that denote this include things like .txt for text, .tsv for tab separated values, and .csv for comma separated values. So these would be examples of flat files. They don't have any extra components to them except for the information that's in there. Now, conversely, things like docx, .pdf, or for an Excel file, you have your XLSX type files. These are not flat files. They're not plain text files. In all of these instances, so specifically from the ones being generated from Microsoft Office, there's a number of other components that get stored as part of that document. A lot of the information about where elements are in the document gets stored. One of the interesting things is that Microsoft uses an alternative return command. So Unix uses a one character to denote that it's going to be a new line. Microsoft uses a completely different one. And so that information doesn't get read properly by the Unix commands. And so you end up in a situation where if you were to try and use one of these less or tail on something like docx or PDF, you're not going to get a result out of it. So working with flat files is something that's very common when you're working in a Unix environment. And you'll see this, right? If you have interacted at all with somebody who does bioinformatics regularly, you might send them an Excel file and you might get back a TSV. And you'll go, why am I getting back a TSV? The reason is because they're working in a plain text format and not working in Excel itself. Okay. So we're going to do the next step, which is about how we actually manipulate documents that exist already on the computer. And so we're going to do that by addressing 2 different commands. CP, which is short for copy, and MV, which is short for move. Copy and move look very similar to each other in the way that we work with them, but they actually functionally very differently and so fundamentally different that they actually can cause a little bit of a problem if you're not aware of how they're going to work as we go forward. So to just start and emphasize up here, copy takes what you're working with and just makes an exact duplicate in a, as long as you name it properly, in a new file. Move takes your file and literally will move it somewhere else by removing the original copy and putting a new copy somewhere else. We can use that style to actually take something and give it a new name, where we're moving it to the same place, but by using move, we delete the original and create a new one. And so we'll show that example as we're going forward. But at the same time, you might use one or the other interchangeably depending on what you're trying to do. Okay, so let me hit clear here to start from the top. All right, so we're going to start, we're in our Unix intro directory. If we hit ls, we get our starting information that we've had in lesson 1, 3 directories, and our example file, example.txt. And so we can copy, make an exact copy of example.txt by using copy. We're going to give it our first argument, which is example.txt. And then we're going to give it our second argument, which is the file we want to create on top, file that we want to create from it. So in this case, we're going to use underscore copy.txt, emphasizing the fact that we're not putting a space here. A space would make the computer think that we're trying to give it 3 arguments instead of 2. And so we're using that underscore to make sure that we understand that there's a, we're creating the copy of the file. So now if we hit enter, that will run. We can hit ls, and you'll see that there are now 2 files, one called example and one called example.copy.txt. And we can check to make sure everything is as copacetic with this, right? So if we do word count dash line on example.txt, sorry, you can see that there are 100 lines. If we do word count dash line example underscore copy, there's 100 lines. If we use less and look at example, open that up, you can see it's the file that we saw before where we're counting up. We can hit Q to get out of that. And then we can do less example underscore copy text. And it's the same file, just a copy of it. Great, perfect. All right, so we can use the information that we learned in our first lesson to take this file that we're working with, and we can move it into other directories or copy it into other directories. Sorry, don't move it yet. Copy it into other directories. So we're taking the file that we're working with and we're making the exact replica while leaving the original where it is in a new directory. So we can do this by looking, so we're going to use our relative path, right? So we're starting in Unix, our intro, Unix underscore intro. There's a directory called data. So based on where we are, we can just type in ls data. And if we tab that out, it'll autocomplete with the /. And we can hit ls, and this will tell us the contents of that directory. And so now we can take copy example.txt, and we can say, okay, take example.txt. We're going to use our relative path that we're going to say in data, now put a new copy of this file that we're going to also call example copy.txt. And so now if we ls data, you'll see that instead of one directory with something called sample, all samples, we now have all samples and example underscore copy.txt. And so if we were to do this without renaming the file, so if we do copy example.txt, and in this case, we just hit data, right? So we're just saying, take a copy of example.txt, and this is the directory I'd like you to place it. We hit that, and then hit ls data. You can see what has happened here is we've taken example.txt, we've left it where it was, made an exact copy of it, and then put it into data here where it's now residing next to example underscore copy.txt. So copy is really powerful as long as you want to keep the original, and either make a file that's exactly the same but with a different name, or to take exactly the same file and put it somewhere else on the computer using your path information and the other directories that you have available to. And so then we can also use this command to take files that are somewhere else and bring them to where we are. So, okay, so we're still in Unix _ intro. If we type ls, this is where we are. We have our example.txt. We have our example _ copy.txt, which we just created. So now what we want to do is from experiment, there's a file in there called notes. We want to take notes that's here and then make a copy of that file in the directory that we're in currently. So we're going to do that using copy, not example, experiment. We're going to say notes here, right? So we're going to say copy in this directory relative to where we are called experiment. There's a file called notes. And now we'd like you to take that file, computer, and make a copy of it and put it where we are. And to tell it that we want it to go where we are right now, we use a shortcut that is a period. So in lesson 1, we talked about the 2 periods, which told the computer to go up a directory. It meant don't look here, look up a directory from where we are. Here it's saying 1 period says, take where you are and whatever you're doing, put it where I am currently. So if we do that and then hit ls, you can see that now we've gone from here. We've now added a copy of notes.txt to where we are currently working. Great. So now let's talk about move and how move functions differently than copy. So in this instance, we're going to hit ls. This is where we are. We're going to hit ls experiment, which will reveal that the notes file that we copied into our current directory is still there. And now what we're going to do is we're going to take this file called example copy text, and we're going to move it into experiment. So watch what happens here. So now we're going to do move example copy.txt. We're going to say go into experiment. We're going to hit enter. And now when we look ls, we'll see that example _ copy.txt is gone. So we've literally taken the file, we've destroyed it, and then we've made a new version of it somewhere else. And so that's important, that distinction, right? We destroyed that original file and then moved it somewhere else. So if we look and do ls experiment, that's where it is now residing. So we've taken it from here in Unix intro, and then we used the move command and we took it and it's now gone and now resides in the experiment directory. And so to give an example of how this also works with renaming things. So here what we're going to do, we're going to start off where we are, where we have notes.txt, and we're going to take notes and we want to rename it. So we're going to use move to destroy the original, but put all the information in a file with a new name. So we're going to do move notes.txt, and then we'll do notes _ old.txt. And so we'll do that command, we'll hit ls, and now notes, which had one name before, has been renamed notes _ old. And you'll notice that the original notes file, unlike copy, which kept our examples up here, right? If we use copy, we kept both files. Here we've now created a new file with a new name and destroyed the original, which has its benefits and elements to that. And so we're going to talk really briefly right now about the remove command. And this will come up multiple times over the next couple lessons and multiple times in your experience with Unix. The remove command does exactly what it sounds like. It will remove a file. Unlike everything in every operating system you've worked in before, Mac and Microsoft, where you delete something and it goes into a trash folder, and you have to then manually go and remove the trash folder, take out the trash. When you remove something, it's gone forever. There's no way of getting it back. That's very important. I'm gonna emphasize that again. When you use remove and you target something on a computer like this with Unix, it's gone forever. There's no way to get it back. I would not say I would say 99.9% of time, chances there are no way of getting it back. So be very careful how you use remove and be sure it's something that you want to get rid of. So in this instance, Notes underscore old, it's outlived its welcome on our computer. We don't need it anymore. We can do remove notes underscore old dot text, hit ls, and you'll see that it's no longer here part of the contents of our directory. Okay, so let's talk about ways that we can interface with our Unix command line and generate content in files that we might be interested in. So here we're going to use a terminal text editor, so a text editor that's in a terminal. It's called Nano. So Nano, it's going to be part of the binder here. It might not be default on your computer. There are several other types of text editors that might be default. You might need to go through the step of installing it. But for right now, let's use Nano in the binder. An example of how we can interact with this information and create new files as we go. So let's do Nano as the demonstration suggests, sample underscore names dot text. So when you give it, when you call Nano, if you give it a name and the name exists, it'll open up that file and it'll allow you to edit it. If you give it a name and it doesn't exist, it'll create a new file with that name. So sample underscore names doesn't exist, so we can create a new one. It'll look a little different than what's here because I have the settings a little differently. So instead of the dark version, it'll be the light version. You can see this is the name that we gave it. There's some information down here about how to interact with Nano, which we'll talk about in a second. And now we can type like we would in any other text document editor and put information as we go, whatever information we want here. So we'll follow along here. We'll call it sample A. We'll hit enter and then call sample B. When we're done, there's like I said, these are the options of how you interact with Nano. What we're going to do is we're going to save this information. We're going to write out this information to this file using this information here. So this little caret means that you're holding control. It does put a capital O here, but you can use lowercase o. So if I do hold control and hit O, it's going to say, are you sure you want me to write this information to this file called samples underscore names.txt? If I hit enter, it'll say, that'll confirm that. You'll see that the modified disappeared right here, right? So no longer is it a file that is unsaved on our computer. It's now exactly what I've typed has been saved. If I were to hit enter and do sample C, modified comes back and I would have to resave it. Like that. I use Control O. Once it's saved, as soon as the modified goes away, if we don't want to be in here anymore, we're going to use this command here, or we're going to hit Control X, and that will close us out of the Nano component and go back into the Unix environment that we were working in. So just to give you an example, you don't have to do this if you're at home. I said that if you type Nano with a file that doesn't exist, it will create it. If you use Nano and you type it in a file that does exist, so if I did example here, it'll bring up that file that was originally here, and now I can go in and I can edit it however I want. I can change it to these are line 2, just to be grammatically incorrect. You can see the modified comes up here, and I can go through the same process of writing it and saving it if I wanted to. If I didn't want to save it, I can hit Control X to exit. It'll say, hey, I don't know if you know this, but you made some changes. Do you want to save those changes? And I can hit N to say no, and then I'll close that out. If I say yes, it'll confirm that I want to save it into the file that I'm working in. I would hit yes and then enter. But for right now, that's just the example I want to show you right there. And so we can look at that. We now have a new file. If we do ls, it's called sample underscore names. And if we look at sample underscore names, it's what we typed in there in our example as we were working for before. And so Mike makes this note, and I think this is really important. This is important for basically all bioinformatics ever going forward for the rest of your life, that it is okay to Google how to do things, especially things like closing out of Nano. And if you need to figure it out, Googling it the first 15 times is very common. There's another terminal editor that's very common for folks to use called Vim, V-I-M, which has an even more convoluted way of getting out of its out of the terminal editor. And to this day, I've been doing this now for the better part of 10 years. To this day, if I accidentally end up in a text editor that's Vim, I have to go and remind myself how to get out of it. It's a pain in the butt. But for the people who use it, it's very easy. So the last thing that we're going to do today, or for this lesson, for lesson 2, is that we're going to make our own directories, right? So this is the equivalent of being in your operating system, saying new folder, and then typing in a new name for your folder. This is the exact same thing, except that we're going to do it on the command line. So right now we're going to hit ls. We've discussed this before. Let me hit clear so we can start at the top and do ls. So we were doing this before. In blue are our directories. In black are our files. So currently we have 3 directories: data, experiment, 6 commands. Now if I use the command make directory, which is mkdir, so make directory with some letters removed, and then make a directory called subset. Now when I hit ls, we have a new blue directory that appears right here. And so the information here that Mike has us working through here is that the opposite of making a directory is removing a directory. And so we can remove a directory. Oh, keep that all as one word. The same way that we make a directory, but the opposite. And now when I hit ls, you'll see that subset is gone. And the thing that is nice about using remove directory, because there are other ways of removing this information, is that it will give you an error if you try and use remove directory on a directory that's full. So I can do remove directory experiments, and it's going to say, no, 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 no. That directory has stuff in it. Are you sure you want to do that? And if we were sure, and that was something that we want to do, we can do workarounds for that. But for right now, we'll leave it at there. If you were to go through, and this will make sense with the next lesson, but if you were to go in to that directory to clear it out, you'd have to clear out all the files that are present there, and then come back out and remove the directory to clean up your workspace. But we'll get to other options for that in the future. So to summarize, we talked about a number of fun Unix commands, including revisiting head, introducing tail, which gives us our last 10 lines of the file, less, which allows us to browse the file and exit using Q, word count, copy, move, and remove, and then the ability to make a directory, remove a directory, and to create new files on the fly where we can type whatever we wanted. And then the special character that was introduced in this particular lesson was the single period to indicate that we're talking about the directory that we're in right now. And so with that, we'll conclude lesson 2. Lesson 3 will be in the next video, where we'll talk about how to use redirectors and wildcards. And so the wildcards will come in with how we might want to remove lots of files at one time. Thank you, and see you in the next video.